For this video, we are going to do 19 through 22, which is writing the number in standard notation. So the given number is in scientific notation. So to write in standard notation, we're doing the exact opposite as we did before. So when you write in scientific notation, you need to make sure the first number is in between 1 and 10. So you move the decimal so that it's in between 1 and 10, and then you reflect how many times you move the decimal, because that's multiplying or dividing by 10, with the exponent. So what this exponent tells us is that in the original number, we had to take the decimal and move it 6 times to get 8.99, and we had to make it bigger than it actually was because this is a negative exponent, so this number is actually smaller. So we are going to move the decimal to the left to make it smaller. So you just rewrite your number somewhere else so you have room. We know we're going to the left, so that's why I left room to the left. So count 1, 2, 3, 4, 5, 6. I want to emphasize that this is not the number of zeros. That's the number of times you move the decimal. Now we fill in with zeros in the blank spaces because those are just our placeholders. So 1, 2, 3, 4. So we end up only having 5 zeros here. So please don't count zeros, just move that decimal. Now you can put a 0 in front of the decimal, but you do not have to. Do not leave your answer like this, because if you notice there's 2 decimals written. We need to go ahead and rewrite our answer. So our final answer, I'll go ahead and put the 0 in the middle, is 0.000000899. And again, we could read this number correctly, but it's really not worth it right now. So that is your final answer in standard notation. Again, make sure when you when you think you have your final answer, that it matches the reasoning that negative exponents are numbers between 0 and 1. Is this number between 0 and 1? Yes, it is. So make sure negative exponent is a small number. Number 20, 3.02 times 10 to the 9th. Again, that exponent tells us how many times to move the decimal. So if we start with 3.02, since it's a positive exponent, that means this number is actually needs to get bigger. So we're multiplying by 10 continuously 9 times, so it's going to get bigger and bigger. So we need to move the decimal to the right 9 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, not the number of zeros. Okay, if you do that, you're going to get the way wrong answer. Now we fill in zeros as our placeholders. Okay, so there's our zeros. And now we've got our answer. Again, do not leave that as your final answer. And let's mark some commas off in here. So here's a comma, every 3 starting from the right. Here's a comma, and here's a comma. So that helps us write our final answer. So it's 3,020,000,000. And that is 3.02 times 10 to the 9th in standard notation. Again, make sure to check at the end that positive exponent gives you a big number, bigger than 1. Okay, for number 21, we've got another positive exponent, so this number should be big. So we're going to take this decimal and move it to the right. So rewrite your number, move the decimal 4 times. 1, 2, 3, 4. Fill in with zeros as placeholders, and let's mark off our commas. So our answer in standard notation for 6.5 times 10 to the 4th is 65,000. Again, big number, greater than 1, so positive exponent. You can also see if you're really good at going from standard to scientific, do it backwards. So now say, okay, what if I were going to take this number, if I was given this number originally, and want to go back to scientific notation? I'd move the decimal 1, 2, 3, 4. 6.5 times 10 to the 4th, and make sure that those answers match. Last one here is number 22. So 1.23 times 10 to the negative 2 power. We're back to a negative exponent, so that means this number is going to be smaller than shown. Okay, so we're going to start with 1.23. To make the number smaller, we divide by 10 twice, which means move the decimal to the left twice. So 1, 2. So I'll fill in with the only place that doesn't have anything with a 0. And again, you can put a 0 before the decimal point. And again, rewrite your final answer, 0.0123. This is small enough we can read it pretty easily. This is the tenths, hundredths, thousandths, 10,000ths place. So this is 123 10,000ths. And that is 1.23 times 10 to the negative second in standard form. That's it for this video. The next video will focus on operations with scientific notation.